way too long to find anything in there anyway.
I would make one.
But we have like a huge pack in it and 2 extra.
So, oh my gosh.
Look at rationals. Sure we
Today we are doing our rational zero theorem. I actually like to call this the rational root theorem. Whichever one we'll remember is fine. So this is helpful in compiling possible roots that we can test using synthetic division. So to compile this list, the rational zero theorem tells me that if we have a polynomial p of x, and this polynomial has integer coefficients, then every rational zero is a number of the form p over q, where p is a factor of our constant and q is a factor of our leading coefficient. I know that sounds really confusing, but we're going to do some examples and it'll make more sense. Good job.
I wrote the same.
I thought
thing
it was
twice.
someone else, but I was too late.
So if we have a polynomial p of x that has integer coefficients, then any and every rational zero that that polynomial has will be of the form p over q, where p is a factor of my constant, which is the number on the end, and q is a factor of my leading coefficient, which is the number on the front.
The worst part is I can't even read it.
I
Okay.
took the whole sentence.
Okay, I'll wait then.
I
No,
wrote the same. thing.
it's part of the middle, so I gotta relook.
I'll give you like 30 more seconds and we're moving on to an example.
Do that in 3.
Good
She's
news
a
is
slow writer.
the
That's the only
notes
thing
are
we want
on
to
canvas for you to look at.
I can't find it. Not that smart.
Your notes are confusing.
That's what I just said.
Trying to figure out what they mean.
It's nice though, because I was so smart.
You were the second slowest.
Yes.
We were always either waiting on you or Shane. There was, if it wasn't one of you, we were
Me,
moving
you.
on.
Well, I had to restart,
Got-
so not fair.
I just walked But you could tell all of us pretty good.
So what we're going to be doing is finding all possible rational zeros for a given polynomial. Our first example is going to be the polynomial f of x equals 4x to the 5th plus x to the 4th minus 2x cubed plus 5x squared plus 8x plus 16. So once I have a polynomial, the rational zero theorem or the rational root theorem, depending on what you want to call it, tells me that if I have a rational zero, that rational zero is going to be a number such that the numerator is a factor of my constant and the denominator is a factor of my leading coefficient. So to make this list of all possible rational zeros, I'm going to take all the factors of my constant and divide them by all the factors of my leading coefficient. So in this problem, my constant is 16 because it's the number on the end that has no variable. And my leading coefficient is 4 because that's the number attached to the variable with the highest degree. If either of those are negative, I take the factors of the positive version. Okay, I'm always dealing with positives here. So before I can make my list, I have to identify what the factors of each of these are. So what are the factors of 16? What else? 1, 16, 2, 8, 4, 4, right? But it's not just positives. We also have to include the negatives because -1 times -16 is also 16. So I list my factors as positive -1, positive -2, positive -4, positive -8, and positive -16. The order that you write these in does not matter. So if you wanted to group them like 1, 16, 2, 8, and then 4, that's perfectly fine. I do the same thing with my factors of 4. What are they? 1, 2, and 4. Because 1 times 4 equals 4, and then 2 times 2 equals 4. Now comes the fun part. I'm going to take each of these and divide it by each of these. We're not going to cancel. We're just literally going to write it and reduce it. So I know maybe that kind of sounds confusing, so let's go ahead and give it a try. What is 1 divided by 1? So positive -1 is one of my options. Yeah, you don't have to write it as a fraction if it reduces. What's 1 over 2? So positive -1/2 is an option. 1 divided by 4. Positive -1/4. And I keep doing this, moving through all of my factors. If I get a number that's already in my list, I do not have to list it again. Okay, so that helps us a little bit. I did all the 1s, now I'm going to do the 2. What's 2 divided by 1? What's 2 divided by 2? Which is already on my list, so I don't have to do it. What's 2 divided by 4? Which is already on my list, so I don't have to do it. Then I do 4 divided by 1. And then 4 divided by 2, already on my list. 4 divided by 4, already on my list. 8 divided by 1. 8 divided by 2 is 4, already on the list. 8 divided by 4 is 2, already on the list. Then I do 16. 16 divided by 1 is 16. 16 divided by 2 is 8. 16 divided by 4 is 4. Okay, so since 8 and 4 were already on there, this is the list. Which means that if I have a rational 0 for this polynomial, it's going to be one of these values. How do we feel about that? Well, for this part.
It might confuse your head a little bit, but
Are we okay with compiling the list?
So you just take the first number with the highest exponent, right, and the last one with the lowest. or the
Right, so
lowest.
this one goes on the bottom, and the last one goes on the top.
You have to have, right? Or is it how it's written?
It'd have to be in standard form.
Okay.
Any major questions, concerns, or issues about how I made this list?
So there's like an AX on the end, you take 8, right?
If there's
Instead of
8x, that's not a constant.
16. Okay, so
It's only a constant if it has no variable attached. So 16 had nothing with it. So that's how I knew it was a constant. So we would pull a common factor of x out of everything and then do it.
okay.
Yeah, so if there is no constant, we have to see if we can make one. But I normally won't give you one like that. I'm going to have you do one on your own now as practice, and then we'll move on into the next step. I know, fun, right?
Isn't this the first lesson?
This is part of it.
I was thinking that too. I thought about that so bad.
Okay, your polynomial to do on your own is f of x equals x cubed minus 2x squared plus 5x plus 12. I just want the list of possible rational zeros. Exactly what we just did on the previous problem. When you have your list, turn to somebody sitting next to you and see if they have the same list. Who just high five? Awesome. You guys can explain how to do it.
Oh.
That wasn't us. That wasn't us.
That's. No, it was Megan.
It was Megan. She did it to herself.
You two do not have the same middle initial, right? You and Pat, you and Paige, no?
Basically, we do. If you two, I have two middle names, so.
Oh my gosh, you guys make it complicated.
Why do you think none of us could tell them apart until like?
Well, no,
middle
I-
school?
Oh, really?
Yeah. And the worst part was like,
Elementary school with teachers. I was also Paige. She was also Patty. Especially in Minutes' class. We did not.
Really?
yeah.
You're right, it's Paige.
Remember when you came in for that
Yeah,
fire drill?
During the food drive last year, before I had to go to my next period, I went in that class and I sat in there for like 6 minutes before he noticed me.
In Paige's seat.
In
Paige
Paige's
was
seat.
somewhere else.
That is fantastic. Oh my gosh. Okay, Miranda and Patty, who would like to start?
I love.
Awesome. What do I do?
You gotta underline the X key in E12. Those are the ones you're using.
Okay, so which one is which? What's the 12 here?
12 goes on top.
So it's the what?
Constants.
And the number in front of x cubed is the leading coefficient. Yes. Okay, so what am I doing with the 12?
That was so.
Okay.
And list off its factors.
So what are the factors of 12?
Plus or minus 1.
Plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5.
Oh, look at that. Hey,
Who else?
fire drill, we are going down these science stairs.
Looks like we don't have to do it now.
That's such a shame.
Just
I don't know, Miss.
Bye guys. Put in the fire.
That was really cool. That was really good. Did you just talk to them? Or? Nice.
Where's my pencil?
I'll just set these up outside.
Forget.
Okay, guys, it's all figured out. Come on, come
Ow,
on.
that hurts.
This is where we all hide in the closet.
Okay.
Honey, I'm
But you're like close to the
Keep the closet.
Oh, gonna hide.
Okay, let's do this.
Boo.
Oh, I know.
No, the fire drill. Nice outside.
know.
We should just go outside. I think we all.
Okay, Miranda and Patty, I did my factors of 12, now what do I do?
Factors of the
Which is?
1 plus or minus.
Super easy. Which means that my list of all possible rational zeros is going to be what?
One,
Plus or minus 2. Plus or minus 3.
All
plus or
of
minus
those
4,
whole
plus or minus
numbers. So that's gonna be it. That is my list of possible rational zeros.
That's
If we have that like that or happens, we just leave it like that.
Yeah, okay.
So
And it happens once in a while. Anybody not get that list?
Obviously not Patty, she said plus or minus
No, I did
5.
not. That was a lie. They are lying.
Okay, any major questions, concerns, or issues that you notice with that? No? Yes, he
I
does.
said no kidding.
Okay, so let's do another one, just to make sure you guys really do understand it.
You think? Yes, we do.
This should actually make it harder.
Oh, why would you put an F down? Oh my.
Fancy. I only like F.
Do I have to use f of x all the time?
Yes.
No, a
Yes.
function can be denoted by any value from the alphabet that I choose.
F is my best.
I could even do Greek letters if I really, really wanted to. No, we could not, well, you could do x of x, but that gets really confusing.
F is-
Unless you have a different variable inside, you could do like x of m, that would work. You kind of just make it up, kind of fun.
how about like a Chinese
Can I
word?
make up my answers?
If you really, really want to. Can't make up your answers, just the function notation.
Well, see that?
Who do I want to call on this time?
You. Yourself.
I think
I'm
that's
thinking
her
this half of the room.
Didn't even give us a chance.
Ooh, I'll give you guys a second.
Oh, we're supposed to be doing this?
Yeah,
Yes,
come on.
Kendra.
Maybe I'm calling on Kendra.
Yeah, you
Yes, you are.
Does not matter. We just take the factors of 4. Yep. That's not a silly question. That's good.
I did that backwards.
Already making open accounts.
Xavier, talk me through it. Okay, I'll give you a second. Brandon, get it started if you're done.
I got, wait. Oh, you can want me to say the whole thing. I got 4 over 9.
Okay, so factors of 4 over factors of 9, right? What are my factors of 4?
4, 2, 1. Negative. Positive.
And then what are my factors of 9?
Or 9, 3, 1.
Xavier, what do I do with those factors of 4? What do I do with all those on the top? Help them out. What do I do with all of these? Divided by all of the bottom ones. So I start with 1 and just work my way to the right. What's 1 divided by 1? What's 1 divided by 3? What's 1 divided by 9? What's 2 divided by 1? What's 2 divided by 3? What's 2 divided by 9? Then I do the same thing with 4. What's 4 divided by 1?
4.
What's 4 divided by 3?
4.
And then what's 4 divided by 9? Okay, so I have a list.
Why did you do
Yeah, it should be. I was checking to see who's paying attention.
Yeah, I'm sure that.
Uh-huh. Okay.
I definitely didn't right time. Wait, no, that's a 4. Never mind.
Okay. Anybody confused by how we did that? Xavier, does that make sense? Okay. So now, what if I actually wanted to use this list?
Oh, no, we don't.
So I have a list of possible rational zeros. Now I want to figure out which ones are my actual zeros. So we can factor them, but that's kind of hard sometimes. Or I could use synthetic division and find out which ones give me a remainder of 0. That's the route we're going to take to start with.
That's still a lot of work.
It is a lot of numbers. Sometimes it's a lot of testing.
This is gonna
No,
fill up the whole
We don't
thing.
love it. Who said that?
We do love it. Come on. We do.
We're trying to do reverse psychology.
Oh, but the good news is,
We gotta find something.
once we get it down to a quadratic as our answer, I can use the quadratic formula to finish it out. So we don't have to use synthetic division to go all the way, just to get us started.
I don't
So,
want-
All the way.
if you would like to get a scratch sheet of paper that you can do all of these charts on, or if you want to do them in your notes, that's entirely up to you. But sometimes it takes a couple before we get one that works. The first thing I want to do is set up my synthetic division chart. So I'm going to do what with the 9, the 5, and the -4?
Oh, make a chart.
Oh, do we just do that? So we
I'm going to do my chart, right? Can I just put 9, 5, and -4 in it?
No, we got to fill up.
We have to fill in with the zeros and the missing terms, okay? So when I build my chart, I have 9 for x to the 4th. I did not have an x cubed, so I put a 0. I had 5x squared. I did not have an x, so I put a 0. And then -4 was my constant.
So what's gonna be?
Hold on. We set up our chart. And we're randomly choosing some number from our list.
No.
Let's start with 4.
You want to start with 4?
Yes.
Okay.
4.
4? Okay, let's start with 4. Just no problem. So we're testing 4 just to see if it works. If it works, awesome. I'm one step closer to my zeros.
That's 36.
So we go ahead and complete our synthetic division. The 9 drops all the way down to my 3rd row. Then I do 9 times 4 to get 36. 0 plus 36 is 36. 36 times 4 is 144. Yeah. 5 and 144 is 149. This is just getting ridiculous.
Yeah.
I
Absolutely.
think this one's right.
That's why we should have done.
What's 149 times 4? I'm at a loss right now.
I don't know.
Oh.
6, 3, 9, 596?
Let me check.
Yeah.
the-
What is that?
Sure.
You can't do the math, but you can do
I
the
think so.
596.
It's 596.
Okay.
Hey, now multiply that by 4. That's like 2,000.
0 and 596 is 596. Multiply that by 4 again. Paige, what do we get?
2,000.
Okay,
You said
2,000.
Paige, go ahead, honey.
2,384. You said we mixed up Patty and Paige.
And then -4 plus 234, 2,384, sorry, is 2,380.
And 8.
Did that give me a 0?
Yeah.
No.
I think we could count.
So I can eliminate +4 from my list because it's not working.
Hold on, we have to do it for both.
So, no, well, they're 2 different numbers. So now we pick a different number from our list. I'm going to suggest we do 2/3.
Oh, that's what I was gonna say.
I'm going to suggest we do 2/3.
Why don't we do it once?
Yeah, I think it's 1.
Doesn't there have to be an easier way than this?
There really is not, unfortunately.
Who created this? Wanna have a
Can
talk.
someone do a project
Nice,
over there but be
friendly.
really passive aggressive?
That would kind of be awesome. Okay, so draw your chart again if you don't have a blank one or you didn't erase all your stuff. And we're going to now divide out 2/3.
Shut up, I'll make it work.
Pick a position.
Okie dokie, let's do this. The 9, that's a 9. That's a 9. The 9 drops straight down. Then I have 9 times 2/3. If you're unsure, do 9 times 2 and then divide your answer by 3. What's 9 times 2? Divided by 3? 6. I drop it straight down. 0 and 6 is 6. 6 times 2 is 12. Divided by 3 is 4. 5 and 4 is 9. I was hoping you did know how to do that. Then we do 9 times 2 is 18. Divided by 3 is 6. 0 and 6 is 6. 6 and 2/3 is 4. Negative 4 and 4 is 0.
Wow.
Why did you suggest
Wait, so one word.
You'd have to figure it out. But
There's too many sims.
I don't believe that. No, it's not.
Did you ever get your mommy?
Oh, yeah, no,
No.
Okay,
I got it today.
so now I only have what kind of polynomial left after I did that division? Do I have a degree 4, degree 2, degree 3, degree 1, what?
2/3. I don't know what we're doing.
Okay, so I think we need a refresher of how to write our quotient. This is our remainder. This is our constant, our x squared, our x cubed. So I have 9x cubed plus 6x squared plus 9x plus 6 left. This is not a quadratic, so I'm not to the point where I could use the quadratic formula, which means I get to do synthetic division again using these coefficients to find another 0 that works.
But nobody likes.
I'm going to tell you which one we're going to test this time to save
Can you
it.
tell
Like,
us on our homework too?
no, but I did not make them super difficult, so they're not super long lists on your homework.
0.
So now let's do our synthetic division again. I set up my coefficients, making sure to fill in any missing terms.
Wait,
There are none, so I didn't.
I'm a little.
That's a fun one.
Why did we rewrite?
Hey,
it?
hold on.
Need that.
Say that again.
Why did we rewrite that? Because we already knew that.
I'm rewriting it because now I'm doing synthetic division with this polynomial. Yeah. Because I'm hoping that once I find one that works, I'll have a quadratic left, and I can do the quadratic formula with a quadratic. Well, there's other ways to solve it too, but. So now let's pick a number from our list that you think is going to work.
2,
1.
No, don't
Okay.
listen to that.
1/3.
Is that what we're at?
2.
Don't listen to that.
2 or 9.
We already did 2/3.
1/3.
1/9.
How about negative 2/3?
What?
Let's try negative 2/3 because that's on my list, so I can potentially use it.
Let's try negative 2/3, AK.
Let's try negative 2/3. This is the only, this is the last example we're going to do today because I don't want to overwhelm you.
I'm already overwhelmed.
So we drop the 9 straight down. 9 times negative 2 is negative 18. Divided by 3 is negative 6. 6 and negative 6 is 0. 0 times that is 0. 9 and 0 is 9. 9 and negative 2/3 is negative 18 over 3, which is negative 6. And I got a remainder of 0.
I think that's on purpose.
9, 0, 9, 0.
So what I want to do next is I want to rewrite this as a quotient with our variables in it so I can use a quadratic formula to finish it out. This was my remainder. This was my constant, my x and my x squared. So I have 9x squared plus 9 equals 0.
Wait, plus 9. Oh, no.
Because we always set polynomials equal to 0 when we're solving for a 0. Do I have to use the quadratic formula on this one?
No.
Why not?
Because you can just use
You can use the
you can
minus
move the
0.
9 over and
Okay.
divide the 9.
Brandon, say it again.
You can move the plus 9 over and then divide it off the 9.
It does not have an x term. I will repeat. It does not have an x term, so I don't necessarily have to use the quadratic formula. I can just move some stuff around and square root. So I subtract the 9 over like he suggested. I divide by 9. Oh my gosh. And I get x squared equals a negative 1. Can I take the square root of a negative? Yes. I never said that all of my roots would be real. Some of them will be imaginary. This just so happens to be one that will have 2 imaginaries. They will have eyes in them, yes. So what I want to do, since I have x squared equals negative 1, is I want to square root both sides. And I get x equals positive negative square root of negative 1, which is what? 1i, which is just I. Because I take the I out.
Negative 1 is I squared.
No, negative 1 equals I squared. The square root of negative 1 is I.
Yeah, that's what I said.
Yeah, so that's why it's I.
Wait, so do we have to write that?
Say that again.
I said it in more complicated.
Oh, okay, got it.
Do we have to put it as I or can we put it as square root of negative 1?
No, I want I. Absolutely.
I'm not gonna.
Because it's no different than pulling an I out and then taking the square root of positive 1, which is just 1. So now is the most fun part, which is just listing our zeros and moving on to the next question. So all of the things that worked are my zeros. So negative 2/3, positive 2/3, and then the plus and minus I got from down here are all my zeros. And I list them in curly brackets. I don't care if you list them separately like I did for the 2/3, or if you list them together like I did for the positive negative I. That is your choice.
I did it both ways because
That's not a curly bracket.
But instead of
that's
putting
a
a-
parenthesis.
just leaving it 2/3, I put plus 2/3.
It's okay. It's so positive. How do we feel about that? So not overly difficult, but it is kind of repetitive and annoying. I get that. So if you're working on your homework for this and you want to use a whiteboard for all the synthetic division tables, I'm fine with that. Okay, because then you don't have to do all of that excess work on a piece of paper and erase or rewrite and all that fun stuff. Okay, there is homework posted on Canvas. You're more than welcome to begin working on it right now because you can definitely do it. I think I only put like 5 problems on there. There's 5? Okay. I didn't think I made it overly long. And it's all this. So all we have in the notes now are just a couple more examples. And then it doesn't really get any more complicated than that. Sometimes you just have to do more synthetic division.
I don't know how to, like, if it wasn't just 9x squared plus 9, I don't know how to do
The quadratic formula. Okay.
That would be
I
a
tried to
good
do it once,
idea instead
and I
of starting
just-
this.